we're going to use the patterns for special trinomials to help us solve word problems. Now this first example is not a super exciting word problem per se, but we'll figure it out. Determine the value of k that will make each trinomial a perfect square. So a perfect square is something to the exponent of 2. If I look at this first trinomial and I try to write it as a perfect square, I know that my pattern is square root the first, put it at the beginning, and I want to square root the last. The square root of 121 is 11, put it at the ends, and then take my sign from the middle, which is a plus. Now, I know this value of k has to be equal to double the product. So this kx has to equal 2 times the product of my two terms in my binomial. So times the x and times by 11. So my kx has to equal 2 times 11 is 22, has to equal 22x. So the only way these can equal each other is if the k is equal to the 22, since the x's are already the same thing. So my answer here would be that, therefore k is equal to 22. Okay, so that should make sense in terms of what we had for that question. We're going to do a similar thing with the next one. The difference this time is we don't know that value of k, which is on the end. So if I go to write that as my perfect square, I square root that first term, I get a 9x. Now if I square root the last term, I'm going to get the square root of k. So this here would be whatever the square root of that k value is, and take the sign from the middle. Now we still need to figure out that k value. What I do know though is that if I took 2 times the 9x, so 2 times the 9x times the square root of k, that has to be equivalent to negative 90x. And in fact, I'm going to leave out the negative sign with that, because I already am attributing to the negative, or accounting for the negative, by writing the negative right here. All right, so let's go with this and see what happens. 2 times 9 I know is 18, so this gives me 18 times the square root of k, whatever that is, and then times x. That has to equal 90x. So the only way that these can be equal to each other is if the 18 times the square root of k is equal to 90. So really I have the 18 square root of k has to equal 90. I could divide both sides by 18 to get the root k by itself. And if I do 90 divided by 18 on the calculator, I get the square root of k being equal to 5. So to undo the square root now, I'm going to square both sides, and I get that k would equal 25. K equals 25. So in here at the beginning, if k was equal to 25, what that makes this bracket equal to is a 9x minus 5 all to the exponent 2. And if we check it, if I take the product of my two numbers here, I get negative 45, and then when I double it, I get my negative 90. So I know I did that correctly. All right, try example 2. Put this on pause. See if you can figure out a diagram for it, and then come up with a plan to solve for the area between the two squares. Okay, so a square of side length, so square means all sides are equal in length, and each side is x take away 3. So I'll try and draw a nice little square here, and each side is equal, and each side's expression would be x take away 3. Now that square is inside of another square. So do my best here to draw another square, and its sides are all equal because it's a square, and its sides all can be expressed as a 2x plus 5. And we want a factored expression, so we're going to need to get an expression and make sure its final form is factored for the area. Now I'm thinking area is length times width, or in this case length squared or side squared, of the region in between the squares. So I'm really looking for this area in here. Okay, so in terms of coming up with a plan, hopefully you came up with a plan, but if you haven't been able to come up with a plan, I'm thinking if you found the area of the big rectangle, or sorry, square, and then subtracted out or subtracted away the area of the inner square, that would leave you with the red shaded the red shaded area here. So if you weren't able to do that, try that now. Put me on pause again, try it, and then check your work. Okay, so the area of the large square minus the area of the small square is really what we want to do here. So area of the large square would be 2x plus 5 all to the exponent of 2. Take away the area of the inner square would be x minus 3 all to the exponent of 2. Square the first. I hate when I keep doing that. Square the first. Double the product would be 10x, and double that would be 20x. Square the last, or be nice, write it out twice, and then simplify it. Take away, and I want to take away the answer I get when I square this one. Square the first, double the product, square the last. So I have 4x, that was a squared there, 4x squared plus 20x plus 25, which has to take away x squared plus 6x, having a lot of technical difficulties. Take away the 9. So that's going to give us 3x squared plus 20x, and a plus 6x would be plus 26x. And then 25, take away 9, should be 16. So that's a plus 16. And then I need to try and factor that because my final expression was asked to be in its factored form. Looking for a common factor first. 3 will divide the first two, but no, it doesn't even divide the first two. 3, no, there is no common factor for this, so I'm going to look for two numbers that will add. This does not look like a special trinomial because I don't have a perfect square number here. This is a perfect square, but the first one's not, so it's not one of those special ones. Adds to 26 and multiplies to, I think 3 groups of 16 is 48. Yeah, to 48. So you need to find two numbers that will do that, and then you can put it decomposition to do it in its factored form. And I will, I think I can move this up. Nope, I haven't got enough room on the bottom of this. Yeah, I will need to do that somewhere. Okay, so in terms of finding my two numbers, I started with 1 times 48, they add to 49, so then I went to 2 times 24, and right away they add to 26, so then I would break down or decompose that plus 26 into a plus 2x and a plus 24x, and then a plus 16, and then we're going to pair these up for a common factor. X is common in the first pair, so I would have that equaling x times 3x plus 2, and then out of the second pair I think 8 will come out, and then 8 times 3 is 24 with an x and a plus 2, so that looks good. Oh good heavens, what's going on here? Undo grouping, I don't know what I've just done there. Alright, so take away 2 there, or plus 2 there. These two brackets are the same, so we're going to common factor that out. We have a 3x plus 2, and our other bracket is going to be x plus 8. Alright, so that's our final factored expression for that shaded area on that question. Moving to the last one. Alright, the area of a rectangle is 2x squared minus 7x plus 3. So that's the area for the rectangle. The length of the rectangle can be represented by x minus 3. What's the expression that represents the width of the rectangle? So try that out, see what you can do, and I'll do a solution in a few minutes. Okay, so area we know for a rectangle is length times width. So that's an L times W there. We know that we're starting with an area of 2x squared minus 7x plus 3, and that has to equal the length is x take away 3, and then times the width, which we don't know. So there's a couple different ways we can do this. We can do this kind of through guess and check, or we can think of this as being a factoring question and looking for two numbers. I'm going to start with that area expression up here. Look for two numbers that are adding to -7 and multiplying to +6. And then you can do it through decomposition. I'm going to show you another way. I know that first term has to be a 2x squared, and I have an x here. The only way I'm going to get a 2x squared when I'm starting with an x is if I multiply it by a 2 and an x. Okay, so if I expand that, that's going to give me my 2x. I also know my two numbers are going to be -1 and -6 to add to -7 and multiply to 6. But that's not really what I'm going to need to have here. Actually it is. That means that one of these numbers, when I multiply them, has to give me a -1x, and then the other pair has to give me a -6x. Well, if you look at what I have already, here's where our -3 times 2x gives us our -6x, which means I would need a -1 here, so that when I multiply the x by -1, I get a -1x. Here's my -6x to make my -7x, and -3 times -1 is +3. So therefore, the width is 2x minus 1. That's the expression, the width expression, the expression for the width. I should have put the word expression in here. Expression for the, there, pardon my horrible scrawl. All right, the other option, if you're not as comfortable with that kind of guess and check and trial and error kind of method, would be to go ahead, find your two numbers, and then start your decomposition process. -x minus 6x plus 3, pair them up, take an x out of the first pair, and you get a 2x minus 1, take a -3 out of the second pair to get a +2x minus 1. 2x minus 1 is now common, and so there is your width, the 2x minus 1, times the length that was given, which was x take away 3. Hope that helps.